Yeah. Huh. Never had a problem with it before, but I don't know. Yeah.
I don't know if it's because I'm running too many systems.
Yeah.
But it's kind of confusing in regards to what's supposed to happen. I don't know why it's not working. Sorry about that, bud.
That's all right.
Do you want to use the?
Yeah, probably just so I don't have to keep pointing at you to change slides. I don't normally use a PowerPoint when I give this presentation, so now we've completely broke it. All right, cool.
Here you are.
Thank you.
Sorry about that.
No, it's all right. My thing didn't work. That's all right. I got a mouse. All right, cool. Guys.
Our next presentation.
Hey guys, my name is Tim Hickel. I'm with Timken Belts, part of the Timken company. If you guys have ever heard of Timken roller bearings or Timken bearings, it's been around since 1899. About 2015, Timken sold off their steel production, which is about half the company, and they started acquiring power transmission companies. Carlisle Belts was the company that Timken acquired. Carlisle Belts actually acquired Dayco Belts back in 2001, and Dayco was the original patent holder of the raw edge V belt back in the early 1900s. So new name, but we've been making belts in Springfield, Missouri since the early 1900s. Been around a long time, a lot of expertise in our product. I'm going to go over a little bit of belt basics with you guys, show you alignment, sheave wear, and then tensioning as well. Feel free to ask questions. Here to help you guys, not to listen to myself talk. I will start off by asking a couple questions. I'll be handing out some deflection tensioners for anybody that answers correctly. First question. Anybody know the difference between these two V-belts? One is a B68 and the other one's a BX68. Yep. I don't know who said that first. Somebody you want to pick a winner for me? Or we just hand out a couple of them? Who said cog first? All right, so beyond cogged, what is another big difference between the two belts? Okay, why? Not quite. So the purpose of the cogs, I'll back up. Purpose of the cogs is not actually for airflow, it's for tighter engagement with the sheave. So same amount of pressure, I can create a tighter loop with a cog belt than I can with a wrapped belt. And therefore I engage tighter with the sheave, and I can use a smaller size sheave and it'll run more efficiently. Any other differences between the two? Sometimes. I think these two belts are actually the exact same price, but some sizes are a little bit different. What? Durability as far as this one will last longer, yeah. I'll give you a thing for it. So the raw edge, there you go. Sorry. So this is a raw edge V-belt, and I usually have a picture up here, but I'm using a PowerPoint instead. You guys actually have a picture. Justin, my lovely Vanna White over there, handed out a service manual for everybody. Looks like that. On the second page, there's a good picture of a wrap V-belt versus a raw edge V-belt. And you can tell that there are more cords in the raw edge V-belt, which is the cogged one on the right, than there are in the wrap V-belt on the left. Cords is what gives belts its strength. So it's just like rebar and concrete. You pour concrete with no rebar, it's going to break and crack and fail pretty much instantly. Same concept with belts. The cords is what actually gives the belt strength. So if they were the same cross section, they both fit in the same size sheave, but I don't have a fabric cover on this one, so therefore I can fit more cords into it, and inherently it becomes a stronger V-belt. Additionally, something you can't tell visually, the raw edge V-belt is made of an EPDM material, which is by all standards pretty much the best material for temperature and for performance that we currently have. Everybody has a different recipe for their own EPDM, but it all falls underneath the category. This is made out of an EPDM material. This is made out of MBR rubber. This can go up to 125 degrees Fahrenheit. This can go up to 250 degrees ambient temperature. This one's about 30% longer life, better performance with the rubber than this one. However, nobody's developed an EPDM material that can bond to the fabric, so therefore we have to use a different rubber product for a wrapped V-belt. So more cords, tighter radius around a sheave for more efficiency, better material. Why would you ever use a wrap V-belt? No, they would run on the same sheave. They perform for the same same product. Think about the cover, right? This is a rubber product, just straight rubber on the sides, more friction. This one has a slicker fabric cover, so therefore it can provide some sort of clutching properties. Think about if you're running a lawnmower, a lot of your lawnmowers that actually drive the belt that drives the actual blade are going to be a wrap V-belt because it allows the belt to slip if you hit a big rock, right? You would rather your belt slip than your gearbox seize up or your motor break, right? Much cheaper to replace a $10 V-belt than it is a couple $100 gearbox. So applications that you need some clutching, you need some slippage, I do recommend using a wrap V-belt. We do have specific covers that can be more slippage than others, right? This is just a standard cover. It's not really a clutching cover, but it will provide more slippage than a raw edge V-belt. Additionally, this fabric cover will provide a little bit of corrosion resistance if you're using chemicals, wash down. The fabric cover can protect the belt a little bit better than just the straight rubber. However, HVAC, assume most of you guys are just work on HVAC applications. I highly recommend using the raw edge V-belt. You don't really need slippage in your applications. You don't have a lot of wash down, not a lot of contaminants. This was much better belt, going to perform probably 30% more efficiently than your wrap V-belt. So a little bit longer life. Sometimes there's a little bit price difference, but overall, better product. Any questions on that? Any questions on belts in general before I move into tensioning and alignment? Anything that keeps you up at night wondering about V-belts? All right. If you think of anything, shout it out. All right. So You're running a fan. It's time to replace the belts. What's the first thing you guys do? What was that? Yep. Lock out, tag out. I usually tell a story. You got one? All right. I usually tell a story about a good friend of mine up in Idaho. He was changing a belt out, helping a farmer friend. He's a distributor, sells V-belts. Up underneath this guy's tractor, changing out a V-belt. Didn't properly lock out, tag out the system. Was talking to him, got his hand pulled up into the sheave. He's had 19 surgeries since. Ambulance took an hour and a half to get to him. If his hand, he had to keep his hand there the entire time, or else he would have bled out. 19 surgeries, really messed with his marriage. A lot of tension in his family just because of that, right? So, sounds silly, but please lock out, tag out your systems. I was up changing a fan with Jed, top of a hospital the other day. We locked out, tagged out, and everything. And wind blew, right, and caused the exhaust fan to move. And maintenance guy was holding the fan with the belt, trying to put the new belt on, and hand almost went up into the sheave, right? Got lucky that he pulled his hand back in time, but it could be dangerous even if you do the right things. All right, so we locked out, tagged out. Next, we're going to relieve tension on the system. Sure, you can cut off old belts. No harm in that. However, to put the new belt on properly, really need to relieve as much tension in the system as you can to be able to put the belt on properly and not roll them on. I understand real-world applications are not as easy as that. However, like I said, the cords give the belt all the strength. So you can't see the cords internally for the most part, but you start rolling on, use a screwdriver to pry on a belt, you're going to start bending these cords, and you cause damage to the cords inside. Say there's 8 cords across here, you damage 2 of them, all of a sudden your belt is 25%, loses 25% of its strength. And most systems are designed where you can't lose 25% of your belt strength, or else the belt's just not going to last, right? So keep that in mind. We're going to relieve tension on the system, take off the old belts, and then we're going to inspect the sheaves. Yep. Andrew, co-worker with BDI over here, he handed out a sheave gauge for everybody. Anybody use a sheave gauge before? Okay. So sheave gauge is really easy to use. It is used to determine if your sheave is worn or not. I have a really worn sheave here. So to give you an idea, this is a B-style sheave. Most of the sheaves are going to have a letter system on the side, number and letter system. So this is a 2B34 sheave. I mean, it's a double groove B sheave, and the 34 signifies whether it's under 7.3 inches in diameter or above 7.3 inches in diameter, right? So I'm going to go on my sheave gauge here, and I'm going to find the B tab. They're all labeled. All right. So here's my B tab, and you'll notice I got 2 different angles. One's going to say 34, and the other one says 38, I believe. And it gives you a little clue. 38 is over an OD of 7.35, and 34 is under an OD of 7.35. So simply going to use the 34, put it inside my sheave, and see if there's daylight on the sides or the bottom. All right, and this one clearly is extremely worn out, and you can see plenty of daylight. And I'll pass this around if you guys want to handle a dirty sheave. Take a look at it. So if my sheave is worn out, it needs to be replaced. Should have there's a good picture of it, right? A lot of daylight there. Another indication, if the bottom of the sheave is shiny, the groove is shiny, that means your belt has actually been running on the bottom of the groove. Belts are meant to be run on the sides of the wall, correct? Right, just like this. Belt engages on the side walls. It's compressed and transfers tension through friction, right? If the belt is running on the bottom, it's slipping, it's not going to run efficiently, and you're going to damage your sheave, and your belt and your system's going to fail pretty rapidly. All right, check for Like I said, shiny on the bottom, damaged sheaves, and if your sheave is wobbly. 50% of all belt failures are due to worn sheaves, right? So anybody guess how often we recommend changing out your sheaves in relation to your belts? What was that? Okay, how often when you change a belt should you change your sheave? And you're right, I mean, it does depend on the wear, but so it's, yeah, you guys are all essentially correct. It's every 2 to 3 times you change out your belt, you should change out your sheave. So if your belts last a year, right, it'd be 2 to 3 years that you change out your sheave. That's on average. Obviously, there's some applications. Check your sheave, make sure there's no damage. But every 2 to 3 times you change out your belt, change out your sheave. I usually say that to a group of maintenance people, and they all look at each other and laugh and say, well, when did we change the sheave on that machine out there? I said, well, it was installed in 1977, so about 1977. So I don't sell sheaves, not trying to upsell you, but it will make your belts last longer if you change out your sheaves. So we've inspected our sheaves, taken off the old belt. Our sheaves are good to go. Now we're going to check alignment. A couple different methods of checking alignment. Easiest one for small setups like this, right, is use just a flat edge. Costs $1.99 at Lowe's, just a yardstick. Simply take it and put it across your sheave. I usually do the top and then the bottom. So just put it flat across here and then look to see if it's touching in 4 points. So I'm touching here, I'm off a little bit here, I'm off slightly there, and I'm touching on this corner. So as far as parallel alignment goes, I'm good. But you could tell, and obviously you guys can't see, but looking down on it, I could see that this sheave is angularly misaligned, and this sheave is slightly angularly misaligned. So I'd adjust the angle on both sheaves slightly, and then I would be aligned. And then I'd check the bottom just to make sure there's no differences on the bottom and that there's some sort of vertical misalignment, and I'm good to go. Why is alignment important? Bearing a belt life, is that what you said? Yeah, essentially. Because, and a little bit deeper than that, but if you don't align your sheaves properly, you can't tension your belts properly, especially if you're using a multi-groove sheave. And you'll be able to see it here because I am slightly misaligned. When we get to the tensioning portion, I will tension one of these belts properly. The other one will not be tensioned properly. So I'll either be over tension on one or under tension on the other. All right, so align it using a straight edge. Simple, 3 feet or less drive system. You get a little bit longer, a little bit more complex drives. Anybody used a laser alignment tool before? Okay, these are really handy, pretty simple to use. Yeah, every manufacturer kind of has a little bit different design. This is our design. Simply turn it on, it's gonna shoot out a little red laser, right? Just straight edge. These are plastic sheaves. They got a couple metal points, but this is magnetic, just simply sticks onto the driver sheave. All right? And then it comes with 2 little buttons. These buttons have little tabs that are adjustable. They're adjustable because not all sheaves are the same width, right? Sometimes a smaller driver sheave is wider, has more of an offset than the driven sheave. So you can adjust these dots to accommodate for any offset in the sheave. And you're going to simply stick them, turn this a little bit, stick them vertically and have the laser go through both slots, and then stick them horizontally and have the laser go through both slots. Once it goes through all 4, you're aligned, right? And this, I could probably see it on the wall over there, not quite, but you're not going to have a drive system. I can see it now. I'm not going to have a drive system any longer than this. So great to use on any drives, longer than 3 feet, simple to use, and magnetic. Any questions on that? Okay. I sell through distribution, so I can't give you an exact price, but they're somewhere probably between $1,500 and $2,000, roughly. But if they, I sell quite a few of them. Amazon in California bought 200 of them from us not too long ago for all their maintenance guys. Super helpful as far as just quickly aligning your system and getting your belts to last longer, because downtime costs you far more than a couple grand, right? All right. Any questions on alignment? Quick and easy, not that hard to do as far as theoretically, obviously, adjusting a bearing or a shaft can be a lot more difficult, but it is super important. All right, so we've aligned our sheaves. We've checked our sheaves for wear. We're going to install 2 new belts here, right? Make sure there's enough relieved enough tension so I can properly put them on. And then I'm going to tension up my drive. So, a couple different methods. Anybody used the deflection tensioner before? Passed out a handful of them so far. So deflection tensioner is kind of the oldest style of tensioning belts beyond your thumb. And I'm not doing a great job keeping up with my PowerPoint here. So there's a good picture of a V-belt tensioner. So you're going to tension your belts to where you think they're close. And like I said, I'm misaligned, so you guys can already see that this front belt, when I put pressure on it, is deflecting far more than this back belt, right? So I'm only going to be able to tension one of these belts properly. The other one is not going to be tensioned properly, and my system's going to run quite inefficient. Okay, so I think that's probably in the ballpark here for this back belt. Now, everybody in your service manual, the second to last page, there's a description of the part, kind of how to use it, and then there's a table. So I'll show you how to use the deflection tensioner. We'll come out with a force measurement of how much force is required to deflect this belt, and then you utilize the table to figure out exactly where you need to be with that measurement. So first things first, I'm going to measure my center distance. So for every inch of center distance, I move my little rubber thing here to 1/64 of an inch. So my center distance, and that's from middle of shaft to middle of shaft, is 26 inches. So 26 out of 64 is roughly a third, right? So I would adjust my little rubber gasket to roughly a third of an inch. And there's a little inch ruler here. We also put dots on the side. And the dots, 26, we're going to put, every dot is 10 inches of center distance. So I'm going to put it right between the second and the third dot, right? And I can pass some of these out so you guys can kind of see what I'm doing here. I might have passed out too many already. Are there more over there, Justin? You can pass out a couple of tables that don't have one. All right, so I'm in between the second and third dot, and I've leveled out this top O-ring to 0. And then I'm going to simply put this in the middle of my belt, use my palm, and I'm going to push down on this tensioner until I have deflected the belt I'm trying to tension this much, right? Now, it's easy to do if you got 2 belts in a system, right? I already have a level built in here. If you're trying to tension a single belt, you can lay something flat on top of the sheave as a reference, or you can find a point in the distance, keep your eye on that point, and deflect the belt, approximately that much. So simply put it in the middle, get eye level with it, and push down. All right, and then I'm going to take my measurement, and I am right at 7.5 pounds of force. Okay? So is 7.5 pounds of force good or bad? That's when I reference my table. So first column says gold ribbon cog belt. So I am using a BX series belt. So I will be in the second set of 4, second one down, BX. And then we are going to just pick an RPM for our motor, right? But it'll be, most motors about 1800 RPM. So we'll go with the 1800. And then I'm going to take a diameter of my smallest sheave. I know from experience these are 6-inch sheaves. Yep. So I will use the 6.0 row here. So BX 1800 6.0, and then I'll pick the last column based on the ratio of my smallest sheave to my largest sheave. So right here in this system, they're both 6-inch sheaves. I'll pick the first column, and I'm looking for a deflection force of 6.0 pounds. If I'm using a 6-inch sheave and a 24-inch sheave, right, I would just pick the last column, the 4.0 or greater. Now, if you look at the notes at the bottom, it says new belts should be installed at 2 times the value. I usually do about 1.5 times the value. So 1.5 times 6, I should be about 9 pounds of force. Now, generic table fits every application, not precise, right? This is just to get you in the ballpark of where you need to be so you don't over tension or under tension your system. So I would set this up. I'm at 7.5. I'd tension a little bit more, get to 9, and I'd be good to go. We say to, yes, sir.
Since I'm an amateur, I don't really know. Should the belts be tensioned? Will they have a different result in their overall package if you have 2 belts in parallel?
No, they should be identical, but they will be different if you're not aligned, right? So another note on our belts, most tier 1 manufacturers like us have a system in place similar to this, but if you buy any 2 BX68 belts from us, even if they're manufactured a year apart, we guarantee that they will be within the tolerance of matching tolerance. So ASTM, the rubber standards out there, have a matching tolerance guideline for all V-belt manufacturers. And in our manufacturing process, we guarantee that any 2 BX belts will be within that length tolerance so that they will run on a multi-groove sheave and you won't have different lengths in belts, right? Within a tolerance, there might be, a very minimal difference, but good enough where you could run your system efficiently and be the same lengths. On our belts, there's a little horse on the side that signifies that it's checkmate. That's what we call this system. 95% of our belts fall within that. There's a couple product categories that don't hit that standard, but that will be signified on the belt. But yes, if you're aligned properly and you're using 2 belts that fall within matching standards, you should only have to tension one of these belts. You shouldn't have to tension both of them, right? Any questions on deflection tensioning? Old school method, very generic, but fairly easy to do with a book and a deflection tensioner, right? And you can Google all these. This is a generic table for most manufacturers. You can find this online very easily. And then the other method I'm going to show you on tensioning. How am I doing on time? Am I good? Okay. The other method I'm going to show you is frequency tensioning. Anybody used a sonic tensioner or frequency tensioner before? Yep. So this is extremely easy to use. Simply turn it on. It's going to shoot out a little red laser, and it's just going to measure the frequency of the belt when I pluck it. All right, it uses light to measure the frequency in hertz. So I've tensioned my belt to where I think it should be. I'll tension a little bit more because I was a little under there. And I'm simply going to put this laser as close to it as I can without touching it, and I'm going to pluck it. And you can hear it beep, and I'll get a frequency reading of 54 hertz. I usually do it 3 times. I might get 52 one time, 56 another, and 54, so I take the average. That'll be at 54 hertz, right? Now, is 54 hertz good or bad? We don't know. Can we get to the website here? So we have an online tool called driveengineer.com. You can go in and create a free account. I encourage you guys to do so. Just takes an email address, company you work for, basic contact information. And it'll allow you to type in your drive based on horsepower, RPM, belt size. Yep. Yeah, if you don't mind. Thank you. Do I have to stay on the screen or can I? Josh, where'd you go? Josh, how do I, can I?
Oh, sorry.
That's all right.
Just go back to the. Oh, I'm sorry. You're going to be doing it up on the screen.
Oh, I have to do it on the screen. Okay,
Sorry,
got it.
I can't
No,
do
you're
it.
good.
Sorry.
All right. So driveengineer.com, I'm logged in, but normally there'd be a little register tab here. This allows you to do a new drive selection. So if you want to change out, I actually was just working with Andrew, and we took a V-belt drive system and we turned it into a synchronous drive system to improve efficiency on the drive, saving the customer, what was the analysis, $2,100 a year per drive in energy efficiency just by switching to a synchronous drive. So I can come in here and do a new drive selection. I can select high torque synchronous belt. I can type in the specs of my drive, and it'll spit out all the different options I have to change from a V-belt drive to a synchronous drive, including the sprocket size, the new efficiency of the system. So great tool to use if you guys, want to either take multiple drives that are similar but using different specs and aligning them to one size to cut down on inventory, or if you want to change from a V-belt to a synchronous drive. So we also have an existing drive analysis. So for this application, I'll select heavy duty V-belt, and I'm just going to make up some numbers here for my imaginary drive up front, but we'll call it a 15 horsepower motor, 1800 RPM, BX belts. I'm using 2 of them on this drive. My diameters were 6 inches apiece, and my length is 68 off of B68s. And my target service factor, I can hit this little magnifying glass, and it'll pull up all different applications here. I know this is probably hard to see for a lot of you in the back, but we'll go down to fans. All right, fans over 10 horsepower. Normal service factor for that application will be 1.3. Hit select, run analysis. So this will spit out all the information, and I don't know if I can. Yeah, there we go. So that'll spit out all the information about your drive system. So if I was running a 15 horsepower motor on this system, based on the parameters I put, my actual service factor would be 1.33. And we were looking for a target service factor of 1.3. So I am right at where I want to be. This is a well-designed system if I was to hook up a 15 horsepower motor to it and run 2 BX68s. Spit out all sorts of information about your system. And then we have deflection tensioning, right? We're using that generic table in the service manual, and it told me that I need 6 pounds of force times roughly 2. I use 1.5. This is telling me based on this drive system, I need to look for a new deflection force of 9.9 pounds. We call out used and new. And new, the reason it's higher is because when we install new belts, the belt is going to inevitably settle into the drive system and lose a little bit of tensioning when you start running it. So we encourage you to install the belt at the 9.9 pounds, run it for 24 hours, and if you can, go back and do one more measurement, and you should be where you need to be right around that 7.6, right? If you installed it at 9.9, it'll settle into the system and fall back down to the 7.5, 8 pound range, which is where you really need to be. And then our frequency tensioning. So type in my drive system, and it's going to tell me that I need a frequency on a new belt of 51.6. I had tensioned it up a little bit more after that first deflection tensioning, and I took a measurement of 54. So I know I'm slightly over tensioned on a new belt. I might loosen it up a hair, take one more measurement, and know that, hey, I'm right at that 51, 52 hertz range, and I'm good to go. You can take this On your drive, you can do save. You can email it to yourself. You can download it. You can print it off. I have customers that will take it, just take this measurement and write it on the side of their machine, 51 hertz. And now they know anytime they install a new belt on that system, they need to be looking for a frequency of 51 hertz. So easy to use. You can save it. You only have to do it once for your drives. You can name them as well. And this will actually save. I believe I can go in here and pull up old drives. And it'll pull up all, I can go to history on existing heavy duty. It'll pull up all the analysis I've done in the past, even if I didn't save it, all right? So super handy. You go to our resources tab and our service manuals right here, all of the different brochures we have for different products. And then at the bottom, there's a form here, PDF, that'll show you that same table that we were just looking at. And then at the bottom, there are some great videos from a guy who knows far more about belts than I could ever know, that will show you how to properly tension and align. So if you ever have any questions, if you get a new employee, they can come to this website and they'll walk you through basically what I did up there, but probably much better. One caveat to this program is it will, all of the, especially the frequency tensioning, is done based off of our belts. Like I said earlier, all EPDM designs, compounds that go into it is different for every manufacturer. So the rate at which our belts resonate with its frequency is going to be different than some of our competitors. So like if you type in, your drive system in here and you're using a Gates belt or a different belt, the frequency is not necessarily going to match. I don't know how far off it'll be, but you're not necessarily going to be looking at the same frequency unless you're using a Timken belt. That's just disclaimer for that. And then lastly, I will show you our Power Miser tool. This is how Andrew and I calculated the cost savings by switching from a standard V-belt to a synchronous V-belt. You can type in your motor horsepower rating here. Let's say we're using a 50 horsepower motor. Your motor efficiency, standard motor efficiency is right about 90, I would say. Let's see if I can zoom in a little bit. I think in Denver, utility kilowatt hours around 15 cents a kilowatt hour. And this will tell you what our standard efficiency is for each one of our different style belts. So a wrap V-belt, you're roughly at 93% efficiency. If you upgrade to a raw edge V-belt, you're at 94. Raw edge cogged belt, you're at 95. So if I'm going to upgrade from a wrapped, B series belt to a raw edge belt, and I have to put hours per year up here. So I can calculate my hours based off of how often I use it. Let's say we're at a hospital and we're running our system 24/7, 7 days a week, 52 weeks a year. All right, that's 8,736 hours per year. And this will tell me that if I just upgrade from a standard wrap belt, call it a B belt, and went to a BX belt, just on that one motor, I will save approximately $1,100 in efficiency just by improving by 2% efficiency. This program doesn't show you efficiency as far as properly tensioning your belt. However, if I'm running 93% efficient and I can improve my efficiency rating to 98, and I'm not saying try to stay with me here, I'm not saying go from a wrap belt to a synchronous belt, but I'm saying that if you properly tension and align your system and you can improve the efficiency in your system by 5%, so go from 93 to 98 theoretically, or 88 to 93, you can save $2,700 a year just by improving the efficiency of your system by properly tensioning and aligning your belt on a 50 horsepower motor that runs 24/7. All right, does that make sense? Huge amount of cost savings just by properly tensioning your system and improving your efficiency by 5%. So something to keep in mind. I think when I look at these numbers, I'm pretty floored that it costs $54,000 to run a 50 horsepower motor all year long. That's crazy to me. But anyways, That's about all I have. Any questions from anybody? Anything that did make sense? Yep, driveengineer.com. Yep. Okay. Cool. Well, appreciate your time, guys. If you got any questions, please get with Josh, and we talk on a pretty frequent basis. So, yep.
What you got going on next? Next is